Okay, so this is the second solution to the second half of today's exercise, and so it's exactly like the solution using query syntax, except this time only use method syntax, and force yourself to use that and see what you come up with. Okay, so without further ado, let's just jump right in. We're going to replace this to do, and the instruction here is get a list of all orders after December 8, 2007. Easy, right? Var newer orders equals orders.where O, given O, return back all of those orders where the order date is greater than datetime.parse, just like we did in the query syntax, 12/8/2007. Okay. All right, and sometimes, when I use the method syntax, it helps for me to verbalize it so I can think about what I'm doing here. Given an input of an order, find me all orders that satisfy this condition. Okay, saying it out loud, articulating it helps you to, or writing it down in an instruction, like in a comment right before you start coding it, always helps me out when I clarify my thoughts. Otherwise, I'm just kind of always randomly moving around. All right, where are we here? At the very top, get a list of orders. Well, it would help if I actually printed them out, wouldn't it? I always forget that step. All right, so for each, var O in newer orders, console.writeLine, and let's just print out what the order date and the order ID. So 0, 1, O dot order date dot to short date string, and then O dot order ID dot to string. Okay, so let's run this. Go up to the top here, and looks like we have 3 orders, and that's what I would expect to see. Great. Part 2. We're using method syntax. We're going to do the same thing, except retrieve the order ID and the amount into a new anonymous type. A little bit trickier visually when doing this with the method syntax, but still entirely possible. So here we're going to go more new orders equals orders.where, given O, give me all the orders, all order individual orders where the order date, here, that's why I was having a problem, where the order date is greater than datetime.parse 12/8/2007, just like we did before. But this time what we want to do, take that result and project it into a new anonymous type. And that anonymous type is going to look like this: p.order_id and p.order_amount. Okay, admittedly, I realize this is a little bit trickier. Come on, for each, var O in more new orders, console.writeLine, O 1. So we get our nice formatting there, and then we're going to take the order ID dot to string it, and O dot order amount dot to string. All right, and then we're going to run it. And it looks like we've got what we would expect to see here. Same thing, this time projected into an anonymous type where we print out the order ID and the order amount. Awesome. All right, just for formatting's sake, let me borrow that. Okay, next up, part 3. Find the order with the largest order amount. Easy, especially since we've already done this one time. So I'm going to go var largest amount equals orders.order by descending. Remember, because in the previous video we saw that ordering by will give us the least to the greatest. Here we want the greatest to the least. So O dot order amount, and we're going to grab the first one, and that'll give us the largest amount. So we're going to write that out. Largest amount dot, well, let's do this. And so then we'll go 0, 1, 2, and we'll just go largest amount dot order ID dot toString, largest amount dot order date dot toString. Keep it consistent with what we did previously. Largest amount dot order amount dot toString. Cool. Let's see what we get. What is the largest order? It's $250. That's perfect. All right. Next up, part 4. Here we're looking for all orders containing widgets. And so this is a pretty important hint. You're going to need a lambda inside of a lambda. The innermost lambda is going to need the any method, and the outermost will use the where. And what I meant by that is this. I took a couple of passes at this. It was hard for me. If you got stuck on this particular one, I completely understand, and more importantly, I would probably wind up using the query syntax in this case if I got stuck like I did on this one. Widget orders equals orders.where, okay, because I know I want to find, I need a condition to look for just the orders that contain order items. So now this is going to be the tricky part, and I needed to look at order items, and I'm going to use the any keyword inside this lambda. So for a given order item, does the order item's product name equal widgets? All right, so this is how we interpret this. Are there any orders where the order items have a product name of widgets? Okay, that's pretty complicated stuff. You know, maybe not for somebody who's just a genius, but for me, things don't come that easy for me. So now let's see if we got the right result. Var o in widget orders, console.writeLine o.order ID. But you know what this did for me? It made me learn the any method just a little bit better. And it made me think through how the lambdas were working and their interactions. The first couple of passes were a complete disaster. All right, so now let's take a look at widget orders and run. All right, so according to this, there are 3 orders, 9010, 11, and 12, that contain widgets in their order items. And that is true. If you look at the setup orders, that's exactly what we find. Great. Moving on. Sum up the value of all order items. All right. Fortunately, this one's a little bit easier. So let's get rid of the to-do. And here we're going to go var order total equals orders.select o dot order amount sum. All right. So give me all the order amounts and then sum them all up together and then put that value here. So up until the point when we call this sum, we're going to get back a list of all a list of enumerable list of order amounts. But now we should just get the order total. Let's run it, and we get 800. So the next one becomes super simple too. We just use that previous one as a template. So var order average equals orders.select o order amount and then average. Console.writeLine order average.toString, and we'll have part 6 finished. 200. Great. All right, next one, extremely difficult for me using MethodSyntax. So if you got stuck on this one, well, you and I were in the same boat. And this one required that same kind of approach that we saw earlier. And I didn't give you a hint this time. Hopefully you recognized the need for doing that. Now the key to this one too, boy, I should have wrote this in a note to you. I hope you struggled. You probably didn't get this. But count can accept a predicate as one of its overloaded versions. We haven't been using it that way, but look at the second version of this. You can pass in a predicate. What is a predicate? It's a where clause. So only give me the count of those that satisfy this where clause. And so this is the equivalent of doing, you know, where and then maybe a count on the end. Okay. So either way, that would work. The key here is what's inside. Okay. Order items. Any. So give me any order items that where the quantity is greater than 1. How many are there? I'm thinking there will be 3. Yes. How many orders have multiple items? 3. The 9012 order only has 1 order item in it. Okay, let's move on. Number 8. Create a flat list of new anonymous types using LINQ to project the fields order ID, order item ID, and product name of every order item. Okay. So var flat equals, and you remember what the keyword was that flattens out 2 enumerable lists? Select many. Right. Okay. So here we go. So flat equals orders.select many. And so we're going to look for order items. Now this part threw me to a little bit as well because there is an overloaded version of this, I believe, yeah, and we need that overloaded version. I didn't demo this, so let me explain here what's going on. The first takeaway is that I think it would be easier if you used the query syntax in this case. Even so, we can still make it work with the queries, with the method syntax. Okay, so here's what we're going to do. We're going to flatten out our order and order items by using select many. Now, the particular flavor of select many that I chose here had this overloaded method signature. There's a collection selector and then a result selector. So the collection selector was this part, and then the results selector was this part. And notice this nomenclature, you know, we've only up to this point seen the input, or you remember what we talked about with lambda expressions. On this side, we see the input parameters. On this side, we see the body. Well, this is the part that you've got to focus on because both of these are required as input parameters in order to project out this new anonymous type. So when we're selecting many, here is the criteria. We're flattening orders and order items. In addition, we're going to project out, we are going to use this result selector syntax to pass in the flattened collections and project out the order ID, order item ID, and the product name. Whew, right? That's a little bit. And again, I think the takeaway here is, if you get in that situation, just default to the query syntax. You're probably going to be better off that way in this case. And it's nice that you can choose either one. So here we go, 0 and 1 and 2, and we're going to print out the order ID. We're going to print out the order item ID. And then finally, we're going to print out the product name. So let's see how this one worked. All right, so here's our flattened list of orders, order items, and the products in each order item. Awesome. All right, so this last one, this was the tricky one, right? It's going to work. You're going to be amazed how similar this actually winds up looking to the query syntax. So var newest orders equals orders.select. Select. Now everything else is going to look a lot like, with the exception of the lambda here. Let me get that out of the way. Everything else is going to look just like what we did previously, because now we're selecting a new anonymous type. Or, I'm sorry, a new type, rather. Not anonymous. We know the name of it. It's called order. And then here, we'll create an order ID equals o.order_ID plus 1000. Customer name equals o.customer name. Billing address equals o.billing address. Shipping address equals o.shipping address. It doesn't matter what order you have these in either. Order items equals o.order items. Order amount equals o.order amount. Here's the biggie. Order date equals date time dot now. Now the other way, okay, yeah, so I think we got everything in there, and then we just want to do a loop through here. For each var o in newest orders console.writeLine and that okay, o.order ID, ID dot toString, and o.order date to short date string. And let's go ahead and stick in the order amount too. I think that's probably a good idea. 2, there we go. o.order amount dot toString. And we are on the cusp of success with this example. Look, we have our new orders with new order IDs, with new order dates, but with that old order amount value still pulled over from the previous version. Okay, boy, that may have been one of the harder exercises and one of the harder days so far. But I wanted to make sure you're getting your hands dirty and really getting this. And the only way you do that is to push yourself on a daily basis just a little bit. And today was a big day. So if you got this far, congratulations. Even if you only got a couple of these, hopefully you, your brain is feeling sore from the workout. Okay, we'll see you in day 10. Good luck. You're doing great. Hang in there. We're almost through this first series. And we'll see you later. Have a good day.